Alright, this video is on Maclaurin series by repeated implicit differentiation. Example 6. Let's look at the first part of this question. Given that y is equivalent to e to the power of 3 inverse tangent x, show the following equation. So how do we show? So first thing first, let's observe the equation y equals to e to the power of 3 inverse tangent x. What we can do is we take ln on both sides so that we have ln y equivalent to 3 tangent inverse x. So differentiating this equation implicitly, I'll have the left hand side as 1 over y dy dx, and the right hand side I will get 3 over 1 plus x squared. So dy dx will be 3y divided by 1 plus x squared. Okay, and most of the time when we deal with implicit differentiation, we'll try to avoid quotient. So in this case, we'll bring the 1 plus x squared over to our left hand side, or in other words, I multiply 1 plus x squared on both sides. So eventually, that is what we are required to show. Right, for the next part of the question, it says this: by repeated differentiation of this result, find the Maclaurin's expansion for y up to and including the term x cubed. So in other words, my expansion must stop here. So therefore, I need the value of y, dy dx, d2y dx squared, d3y dx cubed when x is 0. So of course now we need to differentiate implicitly the earlier equation that we have shown with respect to x. So let us look at this equation here. On the left hand side is a product of 1 plus x squared and dy dx. So we're going to keep the front, which is 1 plus x squared. Differentiating the back dy dx, I will get d2y dx squared. Plus the back, which is dy dx, multiplied by the differential of the front, which is 2x. So this is how we actually arrive here. On the right hand side, 3y, very simply differentiating with respect to x, I will have 3 dy dx. Right, so collecting all the terms to my left hand side, this is what we'll get. Of course, now I need an equation involving d3y dx cubed. So for now, we only have d2y dx squared. So we need to differentiate this equation here implicitly with respect to x. So the same process goes on. We see the first term on my left hand side here as a product of 1 plus x squared and the 2y dx squared. We'll eventually get what we have here. So in this case, I won't go into the detail of it. So this eventually we'll get this. And the second term here is a product of 2x minus 3 and dy dx. After differentiating with respect to x, this is what we will get. So simplifying, I should be able to get this as the end result, involving x, dy dx, d2y dx squared and d3y dx cubed. Right, so to find the Maclaurin's expansion for y up to and including the term in x cubed, as mentioned earlier, I need to find the value of y, dy dx, d2y dx squared, and d3y dx cubed when x is 0. So when x is having a value of 0, my y will be e to the power of 3 times 0, because tangent inverse 0 is 0. So it gives me a 1. Now we sub in the value of x equals 0 and y equals 1 into this equation. We'll get dy dx equivalent to 3 times 1, which gives me 3. Right, the same goes for this equation here. I sub in the value when x is 0 and the value of dy dx equals 3 into this equation, and I will arrive at d2y dx squared equals to 9. And last but not least, for this equation, the same thing goes. When x is 0, when y is 1, dy dx is 3, d2y dx squared equals to 9. I will arrive at d3y dx cubed equals to 21. So knowing that y can be expressed in this manner, I'm going to substitute all my values inside and arrive at the Maclaurin expansion for y. Right, let's look at the last part of this question. Hence, deduce the Maclaurin's expansion for e to the power of 2x plus 3 inverse tangent x up to and including the term in x squared. Right, so notice that e to the power of 2x plus 3 inverse tangent x can be re-expressed as the product of e to the power of 2x and e to the power of 3 inverse tangent x. So we can actually make use of the standard Maclaurin series from the MF15 over here. Okay, e to the power of 2x, how do I actually make use of the standard Maclaurin series? Recall that e to the power of x is equivalent to 1 plus x squared over 2 factorial, and so on and so forth. So e to the power of 2x is simply replacing my x with 2x. So all my x is going to be replaced with 2x. Right? Which arrive at this particular Maclaurin series. As for e to the power of 3 inverse tangent x, we have the answer earlier. So we're just going to make a copy over here. And now all we need to do is actually to expand this whole product of the two Maclaurin series, which eventually allows us to get this as the answer.